Hey guys, it's Mr. C with your Level 6 Math. Today we're looking at Saxon Math lesson number 32. Now this is a tricky lesson. This is a lesson we're going to go over two things today. We're going to go through expanded notation and elapsed time. These are both concepts that trip students up. They're really tricky for whatever reason. So I'll go through it, I'll explain it, and I'm going to put some of my biases in here, especially with this expanded notation. But we'll get you through it. We'll get to the basics, okay? So first, we're looking at the price of a new car. It's $27,000, and a house is $270,000. Which one's more? How do you know? Well, obviously the house is more because $270,000 is more than $27,000. How do we know that? The same way we know that 2 is more than 1. We learned how to count. But Saxon wants you to know that you can take these numbers apart through expanded notation, and that's another way that you can know. So if we take the 2 in these two numbers, 2 here is in the 10,000s column and 2 here is in the 100,000s column. So we can take the 2 times 10,000, and then this second one we can do 2 times 100,000. And because the 100,000 is greater than 10,000, we know the second one's greater. I think that's ridiculous. Obviously we know that 270,000 is more than 27,000 because we've learned how to count. But hang in with me here because expanded notation does show up on year-end tests and your SAGE, your RISE, your SAT kinds of stuff. So it is useful to know for testing. Will you ever use this in the real world? I doubt it, unless you're a 5th grade teacher. So to find a digit's value within a number, we multiply the digit of the value by the place occupied in the digit. To write a number in expanded notation, we write each non-zero digit as a place value. So here's how we do that. We take 27,000 in expanded notation. So first we're looking at the 2. This is in the 10,000s column. So we can just do 2 times 10,000. That's what we'll do for the 2. Then for the 7, the 7's in the thousands column, so we can do 7 times 1,000. Then for all these zeros, we don't have to do anything. So we're only looking at the numbers that don't have zeros. So 2 times 10,000 plus 7 times 10,000 equals 27,000. And we know that because we can just go ahead and multiply that together. 20,000 plus 7,000 equals 27,000. So that's how we do our expanded notation. Write 5 times 1,000 plus 2 times 100 plus 8 times 10 in standard notation. All we're doing here is solving, so we're just doing this as a math problem. Of course, in math, we use the order of operations first, which in PEMDAS, parentheses, exponents, that's our first thing to do. So we're looking at parentheses first. 5 times 1,000 is 5,000, 2 times 100 is 200, and 8 times 10 is 80, so it's going to be 5,280. Pretty easy, that's our standard notation, 5,280. How would that change if we added another 20? Well, then it'd just be 5 times 1,000 and 3 times 100, because 80 plus 20 more is another 100. Okay, so that's it on expanded notation. You're going to have to practice it. It's going to feel tedious. There's a lot of writing on this one. Just do it. Sorry, that's all I can say. All right, so on lapse time, this one is more useful, and this really tricks students up quite a bit, especially when we're going from AM to PM or when we're subtracting time, because we don't subtract time the same way we subtract normal numbers, like 100 subtract 90. Here we're dealing with a clock which only goes up to 60 minutes, so it becomes a little more problematic. So if we look at the AM and the PM. The AM hours are from midnight to noon, and then from noon to midnight, that's PM. So think of AM as the morning time, PM as the afternoon or evening time, okay? So in this example, Jason started his marathon at 7:15 a.m., kind of a weird time for a marathon. Usually you start right on the hour. He finished the race at 11:10 p.m. So how long did it take? Just like we do on elapsed time for years, we're going to take the later time first. So we're going to go 11:10 a.m. and we're going to subtract 7:15 a.m. Now again, we can't subtract a bigger number from the smaller number, and so in normal math, we just cross this out and turn it into a 9. We can't do that in time because we're looking at 60 total minutes. So what we'll do is we'll take 1 hour away. So we'll change the 11 to 10 hours. And that gives us 60 minutes. So we'll add 60 to the 10 we have. 60 plus 10 is 70. And we know 1070 isn't a real time, but for this problem, it makes it possible to subtract. So we just take 70, subtract 15, 10 minus 5 is 5, and then we get a 6 minus 1 is 5, so we have 55 minutes. Then we just subtract 7 from 10, and we get 3 minutes and 55, or 3 hours and 55 minutes, which is pretty decent marathon time. It's a little bit faster than I can go, sadly. I'd like to do 3 hours and 55 minutes. All right, so we take the later time, subtract the earlier time. We look at the difference by doing exactly what I just did, and we'll end up with 3 hours and 55 minutes. That's going to take some practice. It doesn't feel normal to cut out an hour and add 60 minutes, but obviously we know an hour is 60 minutes, so it works, and we can check our math. It's going to take some practice to do that. Let's look at another example. What's 2.5 hours after 10:43? Now, I'll be honest, the way I usually do these kind of problems is in my head, because if I can do 2.5 hours, I can just think that's 2 hours and 30 minutes. So I start with the hours first. 2 hours past 10:43 a.m. would be 11:43, 12:43. Once it gets to 12, it switches to p.m., so 12:43 would be 2 hours later. Then I just have to add 30 minutes. 43, so I'm just going to say what's 10 minutes to 43? 53, 03, 13. So it's going to take me over to 1 more hour to 1:13, and now we're in the p.m. For me, it helps to visualize a clock and just be like, okay, it started here at 10:45, we go 11:45, 12:45, or 12:43, add the half hour, that gets me to 1:13. Of course, we can write this out the same way. So we put the later time first, 10:43. We don't know the later time. That's what we're solving for. So we put the earlier time first, 10:43. We put the difference, 2.5 hours, and then we have to flip that to calculate it. So what we're going to do is, they didn't flip it. Let's see what they did. They did a mental calculation just like me. Okay. And then they switched it. So from 12:43, they added on their 30 minutes, and they did that 12:53. Okay, so exactly the same way I did it. Cool. Sometimes me and Saxon are on the same page. That's great. So, here we go. This is what I thought they would do. So they took 10:43, you add 2 hours and 30 minutes to it. So if we add that up, we get 73 minutes. Obviously there aren't 73 minutes, so that's the same as 1 hour and 13 minutes. So we can just add an hour here. So if we have 12:73, that's just going to be add an hour, and then you're left over with the 13 minutes. 1 hour added to 12 isn't 13, because in the US time system, we go from 12 o'clock to 1 o'clock, not from 12 o'clock to 13. Military time, it would be 13. It would be 13:13 in this case. But because we switch to 1 and just call it PM, then it's 1:13 PM. All right, that's it. I know that was a lot to take in. You might have to watch this video a couple times. Go through the homework problems. Good luck.